We got 3 loops.
Okay, we've got 2 networks, identical except that where I have a 12 ohm here, I put a 3 volt here. And this is going to lead me to replace ultimately this 12 ohm with a capacitor. I've replaced it with a known resistance. I'm going to replace it with a capacitance in a minute. Okay? We write out the equations, just assuming I1, I2. I assumed an I4, but since I neglected to put a resistor in here, and actually it's just as well as I did, we'll just eliminate that I4 out of there. Okay? And I actually wrote an equation out with I4 that was here. It turned out to be completely redundant with this one, which is exactly what you'd expect, because the I4 I had here is just the same as I1, since you have no branching points between here and here. Okay. Now, the 2 systems of equations that I can write are identical, except for the equation that involves a loop that includes this element, okay? And we need a loop that includes that element. In the first set of equations, I just went ahead and wrote down the equation for the outer loop here, okay? And then, I wrote an equation for the outer loop here as well. And of course, the 6 volt and the 3 volt drops, and we have a drop both here and here if we go around the outer loop counterclockwise. Give us a total of 9 volts. And then we have the negative 12 ohms times I1. We divide both sides by ohms to get amps here and eliminate the unit here, as we talked about last time. Yeah.
Just a quick question.